Hey guys, this is the second part of the the video for the review. So we're picking up on question 7. So write an equation in slope-intercept form or point-slope form. Slope-intercept form is y is equal to mx plus b. Point-slope form is y minus y1 equal to m times by x minus x1. Depending on the information given, it might be easier to use one of these equations. But for 7, let's read and see if we can figure that out. So the U.S. Bureau of the Census predicted that the population of Florida would be about 17.4 million in 2010, and then it would increase by 0.22 million per year until 2015. Write an equation that predicts the population of Florida the number of years since 2010. So we're trying to make a formula that will give us that will predict the population of Florida from 2010 to 2015, meaning that the formula that we come up with is only going to be valid for these 5 years. And so now, since we're predicting the population, giving a formula that gives the population from 2010 to 2015, this 17.4 million in 2010 is our initial amount. So if that's the case, we want to use this formula because b represents the initial amount, or the y-intercept. So we'll say that b is equal to 17.4, while the slope is equal to this 0.22, which is the rate at which the population is changing, 0.22 million per year until 2015. So rate and initial amount. So if I use my formula, y equals 0.22x plus 17.4, I now have a model equation for the given situation that's described here. And then after 4 years, so use the equation to predict the population in 2014, which means after 4 years. So I'm going to use 4 for x right here. So y is going to be equal to 0.2 population per year for 4 years plus the initial amount that we had. And therefore, we get y is equal to, now you can just use your calculator here, 0.22 times by 4 plus 17.4. And I get 18.2 million people. So that's the predicted population of Florida in 2015. Okay? For question 9, write an equation. Oh my goodness, sorry. The order in which this is written is incorrect. So this should be for question 8. Write an equation for the piecewise function. For question 10, you're going to graph this piecewise function. Sorry, I didn't notice that. So we're going to write this equation, and it's a piecewise function because there's 3 parts to it. Okay, so we're going to write the 3 parts. So the first part that we're going to write, start with this function given here. This equation right here is a constant. It's a constant line, and the constant is 5. And so it's going to be equal to 5, and then that's going to be equal to 5 for x values less than or equal to -2. So x is less than or equal to -2. That's the first equation, and that's its domain. And then the next equation is right here, so we have to describe this one. This is a linear function, and the slope of this function is 2. So it's going to be 2x. The y-intercept is 0, so I don't need to write that. And then the domain is from -2 to 4. It's going to be in between, right? So that's where this function is in between, from -2 to 4. So -2 is less than x is less than or equal to 4. Okay, and then the other equation, this last equation, let's check its slope. So its slope is -1. So that's going to be -x. Now, what is the y-intercept? The y-axis is over here, so I'm going to work backwards until I get to the y-axis, so that's going to be 3. So plus 3, and that's going to be when x is greater than or equal to 4. That's the domain beyond that point, right? Okay, so there's the equation for piecewise. For 9, we're going to actually we're going to graph it. Now all of these are just constants. So the first value is -6, and here's the domain. It's from -6 to -3. So from -6 to -3 is where this function is going to be contained in, and the value is going to be -6. So we're going to have a line just right there. So it's going to be -6 with a closed dot to -3, and that's what it's going to be right there. Closed dot on each side, so we can see that from that. Then it's going to be -3 from -3 to 0, so it's going to be -3. Is that closed dot? No, it's going to be open. So -3 to 0. There's our function. So -3 to 0. Okay, and then we're going to be 0, so that's here, but from 0 to 3. 0 from 0 to 3. 0 to 3. And then it's going to be 3 from 3 to 6. Okay, there you go. That's it. That's the piecewise function graphed right there. It's a step function. Okay, moving on. So sketch the solution to each system of inequalities. Let's see. So we're going to graph these functions and then graph the inequalities. Notice that these are greater than, so I'm going to graph them with dashed lines. This has a y-intercept of 1 and a slope of 1/2. So okay. Not the greatest, but I guess it works. Okay, and then the other equation has a y-intercept of -2, and then it has a slope of 2. So, okay, and then this is also going to be just dashed, like that. As far as the shading goes, both of these are greater than. So I'm going to be above this line, and I'm going to be above that line. But the shared region should just be that region right here. So this is the shared region. Okay, and that's the inequality graphed. Remember that if it's greater than, you shade above the line. If it's less than, you shade below. If it's greater than with no, like if there's no equal sign with it, the lines have to be dashed. So for this next one here, now for 11 though, we're not solved for y, so I'm going to subtract that so that I get y is greater than -x minus 2. Okay, so graph that has a slope of -2. Sorry, it has a y-intercept of -2 and a slope of -1. And then I'm going to draw dashed lines through for this one right here. Okay. And then I'm going to subtract 4x from that side. So I still have -y is less than or equal to -4x minus 3. And now I'm going to divide by -1 or multiply by -1, whichever one you prefer. So in this case right here, because I am dividing or multiplying by a negative number, this has to change to greater than or equal to. That's going to become positive 4x plus 3. So this inequality has a y-intercept of 3 it has a slope of 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. This one's going to have a solid line. Okay? For the first one, this green equation, we're shading above because it's greater than. So all of that right there. For the blue line, we're also shading above because we're greater than, so all of this right here. So the shared region would be this right here. Okay, on to the next. Here we have a parabola. The vertex is being shifted to the right 2 and down 5. So right 2 and down 5, that's going to put the vertex here. And I'm going to use the 1, 3, 3 and 5 rule. And I have my parabola. This is going to be a solid line, not a dashed line, because we're greater than n equal to. So that means whenever I shade, I'm shading inside of this. Now I have this graph right here. So that's x is less than 3. So that's a dashed vertical line at x equals 3. Remember, if you're using inequalities with x, that's a vertical line, and it's less than 3, so we're shading to the left. So far, our shaded region, our shared region, is right here. And then for our last function, we have a y-intercept at -4, and then we have a slope of 1 over 2. And then this is supposed to be a dashed line. Okay, and we're supposed to shade down. So that's going to be below, meaning that our shaded region is, no, we're shading above it. We're shading above, it's greater than. So that's going to be above, so that means our shaded region is that right there. There we go. Okay, moving on, we've got 13, and this is our last page. So here we have this long description talking about backpack manufacturer that produces internal frame pack and external frame pack. Let X represent the number of internal frame packs produced in 1 hour, and let Y represent the number of external frame packs produced in 1 hour. If the company makes a profit of $50 for every internal frame pack and $80 for every external frame pack, write a profit function and determine the maximum profit for manufacturing both backpacks for given constraints. What is the maximum profit? So here are all the equations that you need for this right here. So instead of you extrapolating all the information and putting them into formulas there, I'm deciding to just give you the formulas instead. And so again, you can see that $50 for every X, $80 for every Y, and then I'm just giving you the constraints here so you don't have to read anything and piece everything together. But this just means that the external and internal frame packs they both have to be greater than 0, the number of them. And then here's some constraints about them. Now I do have some typos here. This right here is y is less than or equal to -1 over 3x plus 6. We're not saying the x is in the denominator because there is a difference. And then this one right here is not supposed to be 2x. That's y is less than or equal to -2x plus 16. And that's a big deal right there. So that should be negative, not positive. So we're graphing these functions. Graphing the first one has a y-intercept at 6 and a slope of 1/3. So that's down 1 and over 3, down 1 over 3, down 1 and over 3. And we get our line like that. And then we have a y-intercept at 16, and we've got a slope of negative 2x, so down 2 over 1. Like that. And don't forget that we had x is greater than 0, y is greater than 0. So think about the shaded region that we would have had. Everything has to be to the right of the x-axis or y-axis and above the x-axis. Everything has to be below both these lines. So below this line right here and below this line right here, meaning that this is our shared region. Okay, so if that's our shared region, like that, we are looking for these intersections right here. So the first intersection is 0, 6. This is 0, 0. This right here is 8, 0. And this right here is 6, 4. Okay? Now what I'm going to do to find the maximum profit of these constraints is I like to make a table of x, y, and z. For x, well, so 0, 0, 0, 6, 8, 0, and 6, 4. So we're trying to see, we're going to plug these values for x and y to find the maximum profit. So I guess I shouldn't really say z right here. We should say p. So if I plug in 0 for x and 0 for y, those are going to cancel. Well, not cancel. They're going to be 0. Sorry. If I plug in 0 for x, 50 times 0 is just going to be 0. If I plug in 6 for y, that's 80 times by 6. I know 8 times by 6 is that's 48, so 480. If I plug in 8 for x and 0 for y, well, that's going to become 0, but 50 times, so 8 times by 5 is 40, so 400 for that. And then when I plug in 6 for x, 5 times by 6 is going to be, so that's going to be 50 times 6 is going to be 300, and 8 times by 4 is 32, so plus 320, so add those together, that's 620, so this is my maximum profit, right there, whenever I sell 6 of the internal frame packs, and then 4 for the external frame packs. Okay, that's going to give me the maximum profit there. 14 through 16 is going to be average rates of change. So find the average rate of change of the function over the given interval. So this is the interval that it's talking about. So from -3 to 0 of the graph. I don't really need the function given here. I know it is there, but I don't need it. So if I go over to -3 on the x, the y coordinate is going to be up here. So right there. And then if I go over to 0 on the x, the y coordinate is going to be down here. And I'm trying to find the slope between these 2 points. So the slope between these 2 points, the run is going to be 3, 1, 2, 3, 4, 5, 6. The rise is 2. So slope is 6 over 3, which is 2. And that's my average rate of change. My average rate of change is 2. Okay. For this one, we don't have a graph, but we are going to use the formula this time because we don't have a graph. And we're going to, so we found the y values here by looking at where the x values are and then looking at the graph. But this time we actually need to plug in these values right here to find the y value. So let's start with 0. So if I plug in 0, I'm going to call it y of 0. Y of 0, if I plug in 0 for x, that's 0 squared minus 2, and that's just going to be negative 2. And then if I plug in negative 4, that's going to be negative 4 squared minus 2, and that's going to be equal to 16 minus 2, which is 14. So now I'm going to put in the formula. So y2 minus y1 over x2 minus x1. So I like to start here, x2 and x1. That's usually the order which I write it, x2 and x1. So if I write my formula, I'm going to have 0 minus negative 4. Now, what am I going to put for y2? I'm going to put the y value for 0, which we found to be negative 2, and then minus 14, since that was the y value for negative 4. And then just do the math, so negative 16 on the top, positive 4 on the bottom. That comes out to be negative 4, and that's my temperature change. For 16, at 6 p.m., the temperature is 79 degrees. At 12 midnight, it is 65 degrees. You don't really need to use any formula here. So if I understand that from 6 to 12, that's a 6-hour change, right? And I went from 79 degrees to 65 degrees. So how much did I change? And I'm trying to figure out each hour how much the temperature changed by. So it's from 6 hours, how many degrees did I drop? So from 79 to 65, what's the change in the degrees there? So 65 minus 79, that's going to give me negative 14, meaning that the change is 14 degrees, and I decreased 14 degrees. And then if I divide that by the number of hours that took place, which was 6, then this right here will give me negative 2.33, and that's degrees Fahrenheit per hour. So we're just saying that every hour from 6 to 12, on average, we drop negative 2.33 degrees every hour. Okay, and that right there should be everything for the review. Hopefully you guys found this helpful, but make sure you ask me any questions if there's something else, okay?